Okay, hi, so I'm Dea Carroll, and today I'll present some of the work I have been doing with Bianca Skelson entitled Analysis of an Espacement Tridimensional Knapp Research Forest. Most of you probably have heard of the 493 plot trial that was established in 1957 by the former Professor Harry Smith at Knapp. The objective of the experiment was to test the effects of initial planting density on the development of Douglas fir, western red cedar, and western hemlock in clear stands. So the objective of our work was to use the 493 plot data and compile the data from the last measurement that happened in 2019, analyze and publish the results using all the measurements, and also point out all the limitations in dealing with an historical experiment. Today, we will only present very partial results focused on western red cedar, but we have been working further analysis with the tree species, including the Douglas fir and the hemlock. So the experiment was designed with 5 different spacings, originally in feet, 3, 6, 9, 12, and 15. Each spacing had 2 replicates for each species. In each plot, we had 5 columns and 5 rows, totaling 49 trees, with exception of the 0.9 meters. They had 14 columns and 7 rows, with double the number of trees. So here's the layout of the design, how it was established in the field. We have hemlock, western red cedar, and Douglas fir. The circles represent replicates number 1, and the triangles replicates number 2. And here I will start to mention our limitations. It took some work for us to identify the locations of the replicates, and we wanted to know because we had very different results from each replication, so we wanted to know their location and the neighborhood. Even that today I'm not presenting any details specific in the reps, just the combined by plot, but we will have that in our publication. So as I say, we found many limitations. One of them is that the first 20 years measurements, there was limited funding and staff time available, and the measurements are done in subsets of trees, so alternate rows and subplots. And also the trees were not identified, and we don't have details of the subsets, right? Which alternate rows these were or things like that. So from 1985 onwards, the Forest Ministry from BC has provided funds for plot maintenance and the measurements. They standardize the measurements with 3 IDs. So in these third 6 years, we have 7 measurements done so far. And even that they standardize the measurements with the 3 IDs, we still find problems. For example, in the beginning of the measurements, not all highs were measured. Also, the mortality protocol changed over the years. So in the few years, we had the trees that died keep being measured so we could evaluate the decay. With that, we found some euros. They're like trees that die suddenly alive. We can see they're alive again on the data set and then they die again. Anyway, so we are using for our analysis only this post-1985 data because we want a tree-level analysis. Also, another limitation is that the plots are too small. So with only 49 trees per plot, with all the mortality through the years, some plots end up with only 2 trees alive. Ideally, we would want 30 to 50 trees to have stable statistics. Leading to another limitation, that is the buffer and edge effects. There were no buffer around the plots to isolate the treatments from each other or outside vegetation. So without the buffer, the growth observed in plot may depend on which treatments or species are adjacent to the edges of the plot. Also, there was a harvest that happened in 2016 that affected most of replicates 1 and some of replicates 2 of hemlock. And this harvest was due for a big mortality that happened at the cedar. We have heard many theories about this mortality. A bomb dropped there, a plant dropped gas, root disease. We're still not clear what really happened there, but really compromised the experiment. Natural regeneration was not removed, so these trees compete with the planted trees that were the fox of this stud. So in some hemlock plots, currently, some natural regenerate Douglas fir makes up for most of the volume. So first we clean the data, checking everything, correcting their errors. We use the outer rows and columns as buffer, analyzing only the trees in the inner 5 by 5. We estimate highs from GBH using the Monezo equation and tree volume using Kozak. Then we compile all the plot level data for many variables, but today we were only gonna show trees per hectare, quadratic mean diameter, and total volume per hectare. We analyzed the quadratic mean diameter plot level statistic from 2014 measurement using ANOVA, following up with a Turkey parallelized test. So here we're gonna look for some data trends of the replicates combined data. This graph shows the trend over time of trees per hectare. The vertical dashed lines are the measurement locations. So we can observe here the effects of planting density on self-thinning mortality. In the highest planting density, lowest spacement, competition for growing space and self-thinning occur early in the stem development and has the most mortality. In the lowest plant density, trees are planted further apart, and this delays the one side of inter-tree competition self-thinning. And we can see that over time, self-thinning reduced the difference in density between treatments. Here is the trend of total volume per hectare. And up to about age 51, the hanking of volume followed the hank of planting density. That is, planting more trees will produce more volume. By age 51, the yields from all the treatments were approximately equal, excluding the 0.9 that had bigger mortality. And I want to note here the drastic mortality we can observe from the measurement 2014 to the 2019. That is the one about the harvest that I just mentioned. So here's the trend data of quadratic mean diameter. The rank of treatments by quadratic mean diameter is inversely related to the planting density. So the plot is established at lower density, have less competition over time, and therefore the average tree diameter is largest. The plots with higher densities have more competition, the trees are smaller. So the rank of the treatment has been mostly consistent since 1985. And because we had a drastic mortality, so for us to zoom in one measurement, we're going to exclude the last measurement, and we're going to zoom in on the 2014 measurement. So here's the quadratic mean diameter took test with 95 confidence interval, and shows that the three widest spacing were not significant different. There were significant difference between the 1.8 with 3.7, 4.6, and between 0.9 and 4.6. They don't overlap in our graph, so the smallest and the highest density. So in summary, this experiment shows planting density influenced the trees per hectare, total volume per hectare, and quadratic mean diameter of Western red cedar. At age 57, yields from a wide range of plant densities were approximately equal. Quadratic mean diameter was inversely related to planting density. In conclusion, we can say that it's very challenging to compile and analyze data from long-term experiments. Changing methods, different standards, different stories. Even with all these limitations, these trial results add to the information from other planting density trials for model building and decision making. More specimen trials should be established to have a better understanding of the effect of stemming density on stem development and yield, using modern stock type, different time frame in different weather events, improving the design with larger plots, with buffer plots shooting contain 10 by 10 core trees with 2 rows of trees around them as a buffer, such as the realized gain trial established by the ministry, designs with more replicates, through randomization, and revisiting the range of specimens to be studied. Also, these future experiments need to have a long-term funding, so it's possible to keep analyzing the data through the years, to have scientific productivity and well-developed partnerships with scientists, statisticians, policymakers, and resource managers. We would like to thank Imajo Cedar Management Funding for the funding, Catherine Statland and Dave Gold from the ministry for providing the data and helping with interpretations. Ian Cameron from Azura Formetrics, who worked with this data back in 1985 and produced all these 10 maps and shared with us and helped with our analysis. Ionit from Knapp that provide us with a lot of GIS files and answer lots of questions. Here are the few references we mentioned today. And just want to say this is a huge topic. I could go on and on and on here, but we are short on time. I hope our publication will not take too long to be out there, and we'll have much more information. If I have any questions, please feel free to ask or send me an email if you want more details on the data or other any specific things. Thank you very much.